Hello students, week 12 physics for grade 12, chapter 40 lesson 1 nuclear fission part 2, page 809 8011. I am Mr. Amir, your physics teacher. At the end of the lesson you will be able to define chain reaction and distinguish between critical mass, subcritical mass and supercritical masses. So what is a chain reaction? Before that, you learned in the previous part that one neutron starts the fission of the uranium atom, and in the example you saw three more neutrons are produced. Most nuclear fission reactions produce two or three neutrons. These neutrons can in turn cause the fissioning of two or three other nuclei, releasing from 4 to 9 more neutrons. If each of these succeeds in splitting an atom, the next step will produce between 8 and 27 neutrons, and so on. You can see here, in each fission reaction there are more numbers of neutrons produced. A chain reaction is a self-sustaining reaction. A reaction event stimulates additional reaction events to keep the process going. Chain reactions do not occur in uranium ore deposits. Fission occurs mainly for the rare isotope uranium-235. Only 0.7% or 1 part in 140 uranium is uranium-235. So the prevalent isotope uranium-238 absorbs neutrons but does not undergo fission. A chain reaction stops as the uranium-238 absorbs neutrons. So, if a chain reaction occurred in a chunk of pure uranium-235 the size of a baseball, enormous explosion would likely result. In a smaller chunk of pure uranium-235, however, no explosion would occur. An exaggerated view of a chain reaction is shown here. In a small piece of pure U35, the chain reaction dies out because the amount is not enough. But in a large piece, a chain reaction builds up. So you can see in a small piece it dies out. In a large piece, or you can say larger one, the reaction is up. So now we can define critical mass. Critical mass is the amount of mass for which each fission event produces, on the average, one additional fission event. So what is a subcritical mass? It is one in which the chain reaction dies out. And supercritical mass is one in which the chain reaction builds up explosively. So you can see at a subcritical mass, the chain reaction dies out, and supercritical mass, chain reaction builds up explosively. Two pieces of pure uranium-235 are stable if each of them is subcritical. But if the pieces are joined together and the combined mass is supercritical, we have a nuclear fission. You can see here, if these two pieces join, then will become a larger one, and it can actually build a continuous fission. A nuclear fission bomb. An example, actually simplified diagram of uranium fission bomb is shown here. Here you can see subcritical piece of uranium at left side and right side. At the same time, TNT means this is actually acting like a catalyst to trigger. So both sides you can see TNT to drive the uranium pieces quickly, and then radioactive source that supplies free neutrons inside. Building uranium fission bomb is not a formidable task. The difficulty is separating enough U-235 from the more abundant uranium-238. So the difficult thing is separating uranium-235 from uranium-238. It took more than 2 years to extract enough uranium-235 from uranium ore to make the bomb that was detonated over Hiroshima in 1945. So uranium isotope separation is still a difficult and expensive process today. Now here is a question for you. What causes nuclear fission? Try to answer your question. Thank you. See you next time.